All right, hi, this is Mr. Roche. We are here. We are trying to implement Quicksort. And what you'll find out from reading the reading in the Java book um, is that um, is that the big thing is the partition. Okay. Um, so in the Java book, we're looking at like partitioning here. Okay. And they go through some partitioning examples, and there's actually a partition um, algorithm. Okay, what we're gonna do is you want to do this. We're gonna kind of set this guy up, right? Okay, and we're gonna try to implement this if we can do it, um, and um, and make it work. Okay, that's sort of the idea. Okay, so the idea is what's going to happen is if you take, it's like taking like one pass at the quicksort algorithm. Okay, so once you get a list, partition it, and then it'll give back where the partition is. That's basically what you're trying to do. Okay, so so going back over here, what we want to do is we want to make a new class. So I'm going to go to sort pack here. Okay, I'm going to make a new class. I'm going to call it quicksort. Okay, and there it is. Okay, and what we're going to do is we're going to have an int num list. Okay, so we're going to carry the num list with us, and we're going to follow the procedure where we have our constructor. Okay, it's going to be just like merge sort. Okay, so I can actually go into merge sort here, and let me see. I want to take the constructor, and I can actually I want to just the guts of the constructor. Go like this, and put it in a quicksort, and then oh actually yeah. So I want a constructor, and the way a constructor works is it has the same name as the class and doesn't return anything. It says public quicksort. Okay. Um, int. I think it's called list to sort. And then we're going to just kind of paste in the what we did before. So this is like just a copying. What it does is that you send it a link to the list that you want to sort. Okay. And then what this is going to do is it figures out the length of it, right? It makes num list to be that big. Okay. So this num list gets kind of created here, and then we copy the values into the list. Okay, so we have our own sort of copy of the list. That's what's going on. Okay, and then we'll make another one public um, public I think it's int get list. Okay, what we're going to do is we're going to return just the list, so people can see the list. Okay. Okay. And so that'll get us the list. Okay. And then from here, what we're going to do is we really do want quicksort. So we'll go like public void quicksort. Okay. And that will like let us quicksort sort it. Something like that. And this is going to be like the major thing that calls the list. Okay. But what's going to happen is, okay, so this will do quicksort quickly, and we'll use recursion, right? But what the text is telling you, and what we saw in the video, and everything we can think of, is the big thing to do is to kind of partition. Okay. Let me see if I can show you something on partition really quick. Okay, so check this out.
Computers often have to sort lists into order, sometimes alphabetically, by date, or some other value. Usually computers can only compare two values at a time. We're going to simulate this by using balance scales to make the comparison. Each container is a different weight, and you need to use the scales to compare them. One approach to sorting them from lightest to heaviest is to find the heaviest one first. This is done by comparing each container with the heaviest one so far. After all the containers have been compared, we have found the heaviest container. We then do this again to select the heaviest from the remaining containers. This builds up our sorted list one item at a time. The list is finally sorted after 55 comparisons. A faster way is to pick a container at random and split the collection into two groups, those that are lighter on the left and the heavier ones on the right. Now all we need to do is sort the two groups. We can do this by using the same method on each group. Pick a container at random and split its group into two parts. The process continues in the same way. Any unsorted group is split into two groups until there's only one container in a group. A single container is already sorted. This method might seem tricky, but it only needed 27 comparisons. That's why it's called Quicksort. For more information about this activity and the Unplugged project, visit.
Okay, so that's what we're sort of going for. Okay, and it's what the little girl did. It's her partitioning that we want to implement. Okay, so going through this for the first time, where she starts comparing and breaking up the list and finding the one segment that's, you know, doing this, getting things balanced from one side to the other, and finding this one. You know, pivot point is great. Okay, that's what we're sort of doing. So that is called partition. Okay, so what's going to happen is it's going to. So what we're going to do, basically, the plan is to take a list, right? I think it's going to have like a start and an end, right? So we're going to say int start and int end. Okay, and then what we're going to do is basically try to partition it, and then for those two list, partition them until the list gets kind of, you know, down to nothing, basically. Okay, but the thing is going to really make this run. I think you do this is we're going to make this thing called partition. Okay, and that's going to be the thing that's really going to work. Okay, so what I want you guys to do is make a partition algorithm, and what it's going to do is it's going to basically sort, find a pivot point. Okay, and the pivot can be the last one on the list, so you can go like this. You can go like int pivot value equals numList of n, and then basically what you're going to do here is you're going to compare all of the other values on the list to the pivot. Then move numbers so that on one side all less than values are there, and on, you can say less than or equal to, and on other side all greater than values are there, you know, around the pivot. Okay, that's what I want you to do, and I want you to do it here. To call it up, what we're going to do is we're going to go to main, okay, and we got to test some stuff out again. So let me see what I got here. Here's my main. Okay, I'm going to make some numbers, like start off making like, you know, 10. Okay, average case, make the numbers. And right now I don't want to do much with merge sort anymore, so I'm going to turn off merge sort stuff. Okay, this is my length, this is my num list. Okay, I'm going to turn off the merge sort stuff. Okay. Turn off non-recursive merge sort. Okay. But what I am going to do is I'm going to go Quicksort, Q, equals new Quicksort. Just like from before, I'm going to send it the num list here. Okay. And then we're going to go Q, just to test this out. This is for testing purposes. Q dot partition, and we're going to send it 0 in the beginning, and we're going to send it num list dot length -1. Okay. And then what's going to happen is we're going to get the list. We'll change this to Q, and then the list looks like this. Yeah. That's what we're going to do. So it's going to print it out, and that's good. So what should happen is you should get a list. You should be able to partition it. What's going to happen is we can test out who the pivot is and things like that. But what it's going to do is basically figure out who the last person on the list was, and you're going to see if where the last digit was, whether it got put in the right place. Okay, and that's what you're going to do. Thanks.